Hi, I'm Eric Blair, and I've been at Baylor for just over 2 years. I've started my third year here, and I've been involved in research in molecular computing. Now, this is important because all the computing in the world is based on transistors today, and transistors are fantastically effective devices, but they waste a lot of power and a lot of energy. So these molecules that we're interested in developing and bringing to fruition for computation applications will allow us to do very high-speed computation, think 1,000 times faster than what we have now, and also enable very energy-efficient computation. So imagine Google being able to slash their power bill by 90% or 99%. And so we want to buy these high-performance computing nodes that will go in the liquid immersion tank and help us calculate the dynamics of these molecular systems. But that's not all, because we're not the only research group that can benefit from this. A lot of other groups in electrical engineering, mechanical engineering, throughout the engineering disciplines, and math and science can also benefit from having high-performance computers like what we want to get here. Imagine if you had your cell phone and you didn't have to charge it for a week or maybe a month. This is the kind of thing we would like to achieve using molecular computing. By donating to our Fill the Tank campaign, you are helping purchase high-performance computing nodes. So these are elements of a supercomputer, essentially, and each node costs about $10,000. And for every $2 that's donated, my research group will contribute $1. So we'll do a 2-to-1 matching. And this will help us increase our capabilities so that we can address this computationally intensive problem, and so that we can share these resources with other Baylor research groups who can benefit from these resources.
My name is Stanley Lin. I'm a faculty in the Mechanical Engineering Department. For my research, I do computational simulation for thermal fluid dynamics problems. And some of this simulation right now, I need to go to the supercomputers in national labs to do it, because in Baylor, we don't have enough computer cores to do that kind of simulation. Right now at Baylor, we have like a 3,000 CPU cores. We know that for some top-tier research university, they have a much stronger computer. So having such a computer will be very important for my research, and I think also for many of my colleagues. They can solve the equations or tackle the problems as impossible before.
Hello, I'm Dr. Elon Terrell. I'm a lecturer in Mechanical Engineering Department at Baylor University. And my area of research is computational tribology. And essentially, my background is in predictions of the lifetime of rotating machinery. For us to do these predictions, we have to use a significant amount of high-performance computing. For that reason, we need a number of computing clusters, and I've used high-performance computing in the past to do those types of simulations. And I hope that we can bring those types of facilities to Baylor so that we can leverage the HPC cluster for this type of work, and we can really build up a tribological prediction at Baylor University.
My name is Jonathan Hu. My research background is in optics and photonics. In my research area, one of the topics is nanostructured devices. So in order to model nanostructured devices, we require very large computational resources. With this very heavy computational resources, high-performance cluster, we'll be able to accelerate our design procedure and make the design process much shorter in order to compare with experimental results.
Hi, I'm Jill Klinsman. I'm a lecturer in mechanical engineering here at Baylor, and my background is in high-speed airflow research. So we look at how disturbances in the air affect transition to turbulence at high speeds. And so we do this by running simulations on the computer to find the growth rates of disturbances, and these types of computing resources would be very helpful in this research. And also I teach computational fluid dynamics to a group of graduate students and undergraduate students, and if they would have these resources to be able to use for their projects and things, that would be very helpful.
Hello, this is Dr. Keith Schubert, reaching out to our alumni, tell you about the Fill the Tank campaign. What we're trying to do is to get the best high-performance computation resources available for the cutting-edge research that we're doing here at Baylor. The reason why we want to do this is air limits how fast we can run a computer. The liquid-filled tank allows the computers to stay cooler so that we can run them faster. That means we can get an instant 50% or more speed up in their performance, and that lets us do wonderful things. My group is also looking at using entropy to be able to improve the scheduling of threads that are running inside a computer. And to be able to look at that, we need to have systems that can run as efficiently as possible. So we're tackling some very large, complicated problems, and having access to systems like what would be made available inside the Fill the Tank campaign will help us to be able to push the next generation of clusters that will help to do a lot of scientific advances everywhere. So we really appreciate all your help. As alumni, it was great having you here, and this is a chance for you to keep on working with us.
I just want to say thank you to all of you who are donating or considering supporting the Fill a Tank campaign. We believe that these dollars will go a long way in impacting the research that we do here at Baylor. We are looking at transforming the world, solving some very difficult problems, and your resources are going to help us do that.